Hey everyone, this is Paul Bemis, and I am hosting this evening presentation along with Paul Puresdorf, who I'll introduce in a moment. The topic tonight is on reducing the risk of pathogen transmission in the built environment, and Paul's going to go over a variety of ways to do that using different technologies. This will be a discussion primarily about the different methods you can use to help to mitigate this issue. Brief introduction to Paul. He's a graduate of our local VOTEC here in New Hampshire, Applied Science, HVAC. He's had a lot of positions. He's gone from sheet metal fabrication to installation to service tech, worked in Boston, worked in Burlington, Mass for Limbach Mechanical. And most recently he's been with J. Lawrence Hall for 8 years as a sales engineer, involved with all aspects of design and implementation in the built environment, and comes to our program today with a tremendous amount of experience, and we're thrilled to have him. Before we get started, for those of you who would like to ask questions and so forth, just a little overview of how this system works. The best way for me to allow you to ask questions is really for you to type them in, and then I can take a look at them and queue them up for the speaker as we go. We will try to answer in order if we can. So if Paul's talking about a topic you're particularly interested on, please type it into the chat box, and I will have those questions over on my display, and I will bring them up hopefully in order. I'd also like to make a shout out to our friends that are our colleagues that are at the Red Blazer in the Fox Den room. Josh is there. I know at least Josh is there, and a couple of others. And I would bring him in, but I can't. So I'd have to. We're going to try to share his webcam here, but I don't see the ability to do that right offhand. So, but for those of you who would like to meet in person and watch these events in person, we encourage you to do that. We do have some people meeting in the Red Blazer, and we'll be doing that each of these events. So if you'd like to come and socialize, we know it's challenging to do that right now, but if you would like to do that, we are trying to figure out a way to do that, and Josh is there today hosting that part of it. So thank you, Josh, for doing that. So let me go ahead and get started here. I'm going to give control here to the presenter. Over to you, Paul. You should be able to share your display now and go ahead and get us started. Thank you, Paul.
Thank you, Paul. And that was a pretty good description of my career, but I'll add a little bit to it. I came from the field. I was a service technician in a truck. I've been on call. I had to account for every hour of my time. And I've touched on a lot of the different facets of the commercial industrial HVAC industry. I've been a service manager. I run a company, and when that company was sold, I welcomed a position to be a sales engineer for J. Lawrence Hall. This is a great company that has allowed me to interact customers, design solutions, keep them in the fold for more business for years to come. And after 47 years, I am retiring. As a matter of fact, tomorrow is my last day. And Josh was able to convince me to do something for him on the next to the last day. So one of the things that I've looked at is that I've been very fortunate to have been given the time to read and research this problem and find solutions readily available. They're really not readily available. You really do need to search them out and do your due diligence and homework to make sure that what you sell to your customer works. So I know it's a little late in my career to put so much time and effort in to learn and then leave, but the day you stop learning is the day that you die. And I am not quite there yet, so we'll move on. First, I'm going to apologize for the extremely low-tech presentation that you'll ever attend. I am a Zoom novice and can only offer a few PDFs as background information and my voice, and I do hope that it will not make you nod off. Try to keep it interesting and move along. I am not an engineer. I only work as one, but I've been very fortunate to have the backing of a number of very talented people in our business, including Josh, who I am actually going to be dumping a lot of my accounts onto. So Have fun, Josh. So instead, I'm not going to be covering ASHRAE's response to the pandemic. You all know that. So instead, I plan on covering the solutions that are offered by different technologies incorporating ASHRAE's guidelines. Although I'm not looking to promote any one commercial company, I am using certain manufacturers' information that's available to share that technology with you. These technologies are not panaceas. They are only part of a complete approach to battling this pandemic. Actually, I never thought I'd ever be saying that word, and hopefully we all will live through it. But I think that our odds are going to be improved, especially if the professionals here take leadership roles in our discipline to design in these protections for the buildings that we occupy. So in addition to the social distancing, hand washing, wearing masks, we need to utilize the existing air distribution systems to first do no harm, as there have been studies showing real occurrences of transmission can be due to airflow. Instead, let's use those systems to help keep everyone safe. Filtration to catch the microscopic pathogens and other dangerous molecules is not easily done in most existing HVAC systems. A HEPA filter can trap the microscopic sized particles. However, most systems do not have the static capability to pull through those HEPAs. Plus, the dangerous particles that are captured are not killed, they're just trapped. In my research, I have found that there are two different technologies that are very effective for disinfecting airstreams at various success rates. Ultraviolet or UV light at 256 nanometers of UVC band, and needlepoint bipolar ion generators, aka NPBI, or needlepoint bipolar ion generators. I'll cover UV first, as that has an enviable 99% kill rate of most pathogens on the first pass of airstream. UV is not new. It has been used to disinfect and treat water as well as food, but it was first commercially used on tuberculosis wards back in the 30s. And even pre-COVID, and funny how 2019 will soon be referred to as that, even before COVID, I have used UV in a number of systems, mostly as coil cleaning, where it is mounted perpendicular to airstream, but across the coil and mounted fairly close. Sometimes on large coils, 2 or more need to be positioned to fully cover the coil. On thicker coils for dehumidification, say they're 6 inches thick, even with regular filter changes and pressure washing on both sides, if these coils are several years old, the middle 4 inches can be packed with dirt, raising the pressure drop, costing energy, also reducing airflow. Before we installed the UV, we took pressure drop readings across, installed the UV, and in a couple of months, we were back to factory specifications on 25-year-old coils. So it really does work. UVC is great for disinfecting, but UVV, as in Victor, is also very beneficial for VOC, odor removal, et cetera, et cetera. I've actually installed them, again, pre-COVID, to take care of garbage smells, smoke smells, cleaning the outside air before it's brought in, especially if it's being brought in through a louver where there is smells, objectionable smells nearby.
Paul?
Yes.
You need to hit the button that says share your screen if you're trying to share anything.
Yep, I got a PDF loaded coming up so shortly.
Okay, great.
So let's actually then see, nope, let's go back to that.
I was pretty sure that's what you were doing, but I had a couple of people asking me that.
So this is Sanuvox, and Sanuvox is probably the better manufacturer that we have looked at. But before we talk about the commercial and the Sanuvox, but at least now you've got something to look at. Everybody was listening to residential use of UV, also called stick lights. And every truck had some, and you were expected to sell them as add-ons, increasing the profit margin. They are mounted perpendicular to the airstream and treat a very small portion of the airflow, maybe only an inch around the diameter and along the length. Some give a shield to reflect the UV and intensify the focus downwards towards the A coil to also clean it. but UVC needs to shine a focused beam, yet bounce it around and reflect it off the sides of the duct to ensure that vaunted 99% kill rate claimed on first pass of Airstream. So Sanuvox and others mount the UV parallel with the Airstream. Let's see if we can get you to that slide. So now you have this would be a bio wall, which has five UVC lights. They can also join in a UVV light if there is any particular VOCs that need to be addressed. So they mount it parallel with the Airstream, and those multiple UVC bulbs of engineered lengths based on the duct sizing for CFM, but more importantly, the feet per minute. This is because the velocity determines the dwell time that the airflow stays in the UVC shine path. You can treat anywhere from 2,000 CFM upwards to 40,000 CFM based on proper sizing guidelines that the manufacturer provides. And you can mount multiple of these bulbs within the larger duct. Let's say that you've got, for example, 100 by 24. So you might have two different bio walls of say 30 or 36 inches in length. They do go all the way up to 48 inches of length in order to get to your CFM. And I think that I can give you a better, okay, so as you can see, the Quattro is only 4 bulbs, the number Quattro, bio wall 30, 40, 50, and all the way up to 60 inches that'll handle the 40,000 CFM. And this is going to tell you what your enviable percent of disinfection rates are. And you'll notice that influenza down here is 91% effective. But you do get the coronavirus at 99.9541. How they come up with these numbers, I do not know. But they are very effective. So one of the things that we do in order to get to that high kill rate is that we remove a 4-foot, we actually include a 4-foot section of aluminum duct to mount the UV in the shop with an access door and a safety switch and an airflow switch to interlock the UV with the airflow. We then remove the existing 4 feet of sheet metal duct and install the new aluminum 4 feet back into the duct system. The door safety switch is to kill the UV if the access door is open, as UV will harm your eyes. If anybody has had a welder's flash, you get that flash followed by a feeling of grit behind your eyeballs. Same for a UV flash. If the flash is not severe or long, you will recover. But why take the chance? For about $100 installed, make the door switch mandatory. UV will also give you a mean sunburn with more damage if you have more than just a fleeting exposure. Why the aluminum duct? It does add cost, but an average 20-ton UV light installation will be around $10,000. Not cheap, but what is the safety of your employees or your customers worth? The reflectiveness of the aluminum versus sheet metal isn't even close. Each of the multiple bulbs also have a parabolic reflector. Let's see if I can get back to the other slide that will show on.
Question while you're doing that, Paul, is dwell time. So you need enough dwell time, which means you need the air to be in the residence of this light for a long enough period of time to kill. Velocity, therefore, is really important. It has to be long enough. And that implies that you have to have enough straight duct space to be able to insert this guy into, right?
That is correct. And although everybody always tries to get away from turbulence, turbulence here is good. And by having it mounted in the middle of the duct like it is, the airflow is going to hit this and roil and tumble. And you can see the reflectors on the other side of the light that is bouncing it off of the aluminum and back and forth. So as long as you have a straight enough section to physically mount whatever the, let's see if I can get back to the pathogen. As long as you can get whatever the length is in the duct, that dwell time as it rolls across the length of the bulb will give it longer time. That's the reason why they prefer you to mount these in the return air, because typically your return air duct is set at a little bit lower friction and will always be a larger duct. But
Which
if you
lowers the
can't put
velocity,
it
lowers the velocity and gives you better dwell.
exactly,
Yeah.
exactly.
Yeah.
So as long as you can, fit it into the duct, it doesn't matter that it's immediately before or after a transition or an elbow. As long as you've got enough room to put it in, that's what you need. So the access door is to wipe down the bulbs on a quarterly basis because, even with your filters and your coils and whatnot, there's still always a residue of dust that is going to land on the bulbs or on the reflectors. So it's to wipe down the bulbs on a quarterly basis, inspect the bulbs, and then change them after 15 to 17,000 hours of runtime. So that's the real reason for the airflow switch, as it cycles the UV only on airflow. So if you're having this in the duct and you're nowhere near the rooftop unit, the air handling, whatever mechanical system you're installing it in, you don't need to be near it in order to have an interlock with the controls of that system. They do have BIOS screens that can be connected from Sanuvox to, let's get back into the commercial brochure. Let's see if we can, so there's the coil cleaning. And let's see if I can find, oh, this one, I apologize, this one does not have the bio screen on it. But that bio screen can also help you interlock, but a lot of businesses and buildings just don't have BAS systems, building automation systems, energy managements. So instead, if you're going to be mounting this separate and away from the unit, then that airflow switch is going to sense the airflow and light the UV light only on airflow. So you don't need to spend the money on irradiating duct with no airflow, even though they only draw around 6 amps, and these can be wired to 110 or 277 or 480 for your voltage. So how long is 17,000 hours? Well, if you ran these lights 24/7 on a 365 basis per year, that's 1.9 years. If you have it set up on an energy management or even just a programmable smart fan thermostat, and you do a 12-hour occupied time, that brings your lifespan up to a little under 4 years. When you are changing the bulbs or cleaning them, never touch them with your hands. The oil left behind will damage the bulb. Always wear gloves. As a matter of fact, when they sell you the UV light, you're getting a pair of gloves with it. So on top of safety to humans and preventative maintenance, you also need to be very careful of what the UV shines on. It will have a photo degradation effect on any organic in its path. So if there is anything that is able to be damaged over time, and it doesn't kill it immediately, it just with the photo degradation, it does it over time. You can use aluminum foil tape or a roll to cover anything that you realize will be exposed. If you are around the corner from something, you're okay as long as it's not shining directly on it. However, for people and their eyes and your skin, about a 4-foot distance of the glow. So in other words, if you had a return air grill immediately around an elbow and the UV light was in the horizontal duct around the other corner, that glow would be seen through that return air register if it wasn't louvered properly. So as long as you give it at least about 4 feet, then you're not going to worry about any issues. So let's scroll through this again quickly to see. We've talked about the UV light, and actually they are listing ASHRAE. And here's the coil cleaning against it. But the interesting fact is that you're getting your 99% this way, but if you're mounting this way, you're shining on the coil only. And of course, you can see that as the airflow is coming across, it's being blocked by the parabolic reflector that's further shining and intensifying the UV light. So you will irradiate some of the airflow, but you're only getting about a 40% kill rate. Now you can still get to the 99% by multiple passes, but the better part is to mount it the way that the manufacturer indicates with the airflow. So then here's the smaller Quattro. This has a built-in airflow switch. You got to make sure that the pitot tube is shaped, is pointing in the direction, pointing against the direction of your airflow. This has the 4 bulbs. These bulbs are only 18 inches long, and the entire Quattro is about 2 feet. You may or may not need to have the additional access panel to clean these, because you just undo the screws and physically remove the Quattro. The door switch may not be necessary because these come with a 110 volt plug that you could get your electrician to give yourself a duplex outlet above the ceiling near the duct. And of course, in order to remove it, you're going to want to unplug it. They also bring you warning signs to put on the duct that there is UV behind and that it is dangerous to humans. So the EPA, as well as a number of other organizations, have the proven results with the testing. So here's the biowall. This is the ballast. The biowall also comes with a 4 or a 5 foot lead that goes into the ballast, and then your line voltage goes into the ballast. And then they also have connection points for your interlocks, for your door switches, your airflow switches, et cetera, et cetera. And so they do have a patented UV sensor capable of mounting the UV output. So you'll see the lamp in real time, guaranteeing the output. That's where they want to guarantee a specific dosage. And all of this information, it's readily available on Sandovox's website. And all of the information in the PDFs that I'm giving is all available online. So I think that that's an important thing. You know, train yourself. You'll find that there's a wealth of information out there, as everybody knows. Here's some of the other things that they do for the standalone purifiers. The portable, this is actually can be like a side stream filter. You can mount it on the return air. They have this mobile room sanitizer, and then they've got this behemoth that you could put in a room if you wanted to and get up to 1,000 CFMs. This is no longer the ceiling tile mount. That's no longer manufactured. That would have been a great thing. So these are some of the things that they believe that they can help you with. And like I say, go to Sandovox. They are a Canadian company. And I have to tell you that we started off with 2 to 3 week lead times. And when that was back in March and April, when we were first starting to look to install these. As of now, we are upwards of 20 weeks on the lead time. Reason for that long lead time is that there's dozens of UV light manufacturers, Sandovox among them, American Ultraviolet, et cetera, et cetera. There's dozens of those manufacturers, but there's really only 4 or 5 UV bulb manufacturers. And they ended up going, with COVID first came in, they had about a 50% absentee rate, and they lost a lot of their production. Once they geared back up, they are running 3 shifts a day for 6 days out of the week, and they are still not able to catch up. So that's part of the reason why there is such a long lead time on that. So I've shown you the disinfectant list, the biowall. Okay, so here's another great thing that Sandovox does. is the bio wall. This is something that the reason why they want to know what the tonnage is, what the CFM is, what the duct size is, and then they will design that bio wall or that length to fit the exact CFM and feet per minute to make sure that they get that vaunted 99% kill rate. So being the delivered dose as 4, so you can see how it is. So this is an end view looking at the duct, and that is your bio wall right here. And by getting that immediate shine, you can see that it starts to deteriorate and diminish as it gets further and further away. This is only a 24-inch, and what I've done is I've eliminated the customer, and they will actually put your customer's name in here and give detailed information about the system that this is being used on.
So that's a little bit more of a custom kind of solution there, Paul?
It is. It is.
And
so then they'll also, if you're indicating that you're very worried about corona or influenza or tuberculosis, they will put whatever the pathogen, allergen, VOC, or whatever it is, and tell you what your minimum and average and how many passes it will take for you to reach that. So as you can see with tuberculosis, you need to be, at least 3 passes to properly kill it in order to get up to that 99%.
Can you zoom a little bit on your down on the lower right hand corner? Can you zoom just a little bit, Paul? There you go. Perfect.
Yep. And the reason why I've done that is because I don't want to have this herky-jerky motion.
I know it.
If everybody can't see it, it's a useless slide anyway. So let's blow it up. So this is going to tell you that they wanted to put this in a 42-inch duct by 24-inch duct. And this is going to show you the waves and how they are disinfecting that influenza. Then they'll show the same pattern with the tuberculosis. And this is telling you the positioning diagram to put it in the center of the duct. So let's. Let me put. So then the next thing that we can talk about is the haiku from Big Ass Fans. God, I love that name. So if you have a room that has no ductwork in it, this is called high room UV. It is actually, this is not passive, but it is a version of high room UV. What they'll do is that you'll have a room, and if you go to Sterile Labs, is another manufacturer that does the passive high room UV, and they will put the proper number of UV lights around the perimeter of the room at above a 7-foot level, and you got to have at least an 8-foot ceiling. So if they put it at the 7-foot level, then they have angles, they have louvers that angle the shine upwards. So even if you look at it, you might see a glow, but you'll be more than the 4 feet away and it will not give you any damage. But it's static and it has to wait for those air patterns to just roll around in order for it to get killed. So if you put a paddle fan in the middle, then that's going to help draw the air up from the occupied zone into the kill zone at the 7 to 8 feet. But Big Ass Fan came out with this idea that we're going to put a UV light onto a paddle fan. And that paddle fan then gives you this circulation from the occupied area up into the kill area. And they make them all the way up to 52, 60, and 84. Let's blow that up. 52, 60, and 84-inch diameter operations. And they can be put in a very nice residential area, or if you go to, like my gym, for example, has a Big Ass Fan. I know the YMCA has one. And this is to give you that feeling of airflow around you and help move things around, well, that is perfect for this upper room UV. And if you wanted to take out the original big ass fan and put this one in, then you're going to get yourself your protection. And you can go to, and this is something that I just pulled off of the internet as a PDF. So let's look at one more thing that we can do. And does this look familiar, Paul? This is
I recognize that thing.
Right. Yeah, this is something that Paul brought over to our office, and actually, quite frankly, we were pretty impressed by it. This is, and as a matter of fact, by bringing in your air, and this is only about 24 inches long, and this can be made for two different 800 and 1200 feet per minute for the velocity. And by bringing that air in and focusing a high velocity up, this is bringing this, so this has a high static fan inside, a HEPA filter, and can be given a UVC light, so that now you've got this barrier between a cashier, a teacher, and the students. You could dream up all of your different applications, but this is something that I think will catch on. And I think Paul would, if you want to say a few more words about it, you're the expert on this one.
This is I think the unique thing about this one is that it's portable, that you can take it with you, you can set it on the desktop, you can turn it on. So there's that. And the other part is that it's I got this high-speed plume coming out of it. So much like the earlier one, the haiku, how do you say it? Haiku?
Haiku.
Yeah, the big ass fan. Similar approach, move the air. And the high-speed plume here, the high velocity, will mix the air in the room and drive down concentrations quicker than would otherwise be done by a device. There's a couple of ways to go about solving this problem, Paul, and you're quite aware of them, I'm sure. The static pressure on these HEPA filters is so high that they generally use a big surface area to get the air through them. So they end up being big, kind of clunky. The other way to do it, what we did here, is make the package small, use a high static pressure fan, and put the filter sideways so you do have as much surface area as you can, and then create a plume. And the plume, what it does is it forces mixing in that room and therefore drives down concentration, as you pointed out. Similar idea to the haiku with the fan overhead. Very similar idea, except this one does include the HEPA, and that one's just a UV, but similar idea.
Right. So, you know, it's not a plug. It was just a great example of individual innovation and entrepreneurial spirit. So hope it works well for you. So that was the UV portion. Let's get into I-wave. So I-wave is the needlepoint bipolar ionization. So these are generators, I-wave generators, that have various sizes as far as CFM. These treat a lot lower CFM volumes. So nobody wants to say needlepoint bipolar ionization all the time. That's why it's been shortened to NPBI. But ionization can also create ozone, and that's the reason why the needlepoint as part of the description is very important. Ozone is a powerful disinfectant. It can eliminate VOCs, mold, mildew, etc. Interesting story is that I have friends that live right on the Merrimack River. And if anybody remembers the Mother's Day floods from a few years ago, well, it inundated their cellar and the mildew smell just wouldn't go away. The cleaning company came in and said, okay, leave, take all your plants and animals. They plugged in a number of ozone generators, and when they came back 12 hours later, opened up all the doors and windows, flushed out the dangerous ozone, and found the mildew smell gone, but along with dozens of dead insects littering the floors. That's the reason why they wanted them to take their plants and their animals out. Bottom line, ozone kills. It kills everything, and it is not what we should be introducing to our environment. And luckily, the EPA has put limits on the ozone that can be utilized. So we have to be very careful about what we recommend to install. Excuse me. So many of the older electronic air cleaners or precipitators back in the day were basically bug zappers that did create ozone as a byproduct. Ion generation dates all the way back to corona discharge technology in the early 1824 by Hohlfeld, and that's spelled Hohlfield. Pretty enlightened scientist. It was furthered by Frederick Cottrell in 1907. And today it's much safer with many beneficial applications. An NPBI ion generator produces a refined electrical discharge that creates millions of positive and negatively charged ions. They only live about a minute to a minute and a half, but these molecules can also clean coils like UV as they attack the like-charged molecules and deprive them of hydrogen so that they cannot reproduce or infect. Not only will they clean the coil, but they will continue along through the duct, cleaning, disinfecting as they go, and out into the conditioned space looking for more pathogens, allergens, mold, VOCs, everything that they can bond to and make inert. And when all are attached together with the like-charged molecules, they become large enough to be captured by a standard MERV 8 or the recommended MERV 13 filters that nobody can buy because they are the same filtration media that's used in the N95 masks. So that's the reason why there's such a short supply. So you don't really need the HEPAs anymore. And the HEPAs you really couldn't put in a standard system anyways because of the static. So this gives you that ability to disinfect, clean, as well as filter without going the route of HEPA. So the ions, and let's see if I can get a better picture. So these are the carbon fiber brushes. And so one emits positive ions, one emits negative ions. And this little bar here is nothing more than a cleaner. And you can set this up to rotate once every day, 2 days, 3 days, 5 days. And all it does is rotate and brush off any buildup of corrosion that might have built up on these carbon fiber brushes. You also want to make sure that these brushes are less or more than 2 inches away from any conductive material, because I'm not quite certain whether they will arc out, but they will disrupt the free flow of the ions. So it's not a good thing. So you want to make sure that these are mounted nowhere near anything that is conductive material. Typically, they want you to put them between the filter rack and the coil.
What is the power consumption on these guys, Paul? What are these?
The power consumption, these will run on 24 volt. They'll run on 110 volt or 208 volt.
So they're low power.
Very low power. They're about 10 to 12 VA on 24 volt, which we recommend. Excuse me. So we recommend that you install them, and these will last a lot longer. I've heard that they will go 5 to 7 years before you have to replace the carbon fiber brushes, which are relatively easy to do and relatively inexpensive. But why make them pour these millions of ions into dead air? So by having an interlock, what we're typically doing when we're doing the installation, and we're already in the high dozens of these, and we will soon break into the hundreds. They are selling like hotcakes. What we want to do is we'll take a 24 volt transformer and put it to the load side of the fan contactor to power the 24 volts. At 10 or 12 VA, typically your control transformers are only 40 VA, and you're going to get pretty close to the capacity, and you'll start chattering relays and not producing the proper amount of ions. So that's why we don't use the control transformer for $15, put another control transformer in, wire it to the load side of the fan contactor, and then that means that the I-wave is only going to be powered when the fan is running. But you do have to be careful if you've got an ECM fan motor, and these are going in furnaces, they're going in fan coils, they're going in anything that has an ECM fan motor, you're going to get that varying voltage and amperage. And so you can't really tie it. You can't really tie the I-wave to that same power going to the fan motor. So instead, we would put the transformer somewhere where it's can be interlocked, and then put a variable, an ECM or a current transformer that you can adjust that will sense very, very low amp draw. And then that becomes your interlock. Get back to my notes here. So the kill rate on these are only about 80 to 85%. Certainly not near the 99% on first pass, but all you really need to do is get a number of air exchanges, get multiple passes. And, if you're doing, 3 to 5 air changes an hour, you're easily going to change the air. If you're worried about if there's some things that are still hanging around, then turn on the fan. Use that smart fan thermostat and turn your fan on 1 hour prior to occupancy. And that way you're going to get those air changes, and you're going to have your occupants come into a space that has already been cleaned and disinfected. So, 80 to 85% is still pretty impressive. And when you stop and think that these installations are anywhere from $1,000 to $1,500 per, depending upon the various sizes, and let's get into those. And this is going to also give you more information on how, is there a way that I can print this? Yeah, there we go. So it's going to give you the harmless compounds of oxygen, carbon dioxide, nitrogen, water vapor. And I had somebody that indicated that they really wanted to know what those percentages were. And I said, well, when I called I-wave, which is manufactured by New Calgon in association with Global Plasma Solutions, or GPS, they both make these. It's a joint venture. When I called tech support and asked, they said, look, 90% of the byproducts are water vapor. And when you stop and think about all of these combined to the 10%, and you're talking a molecular basis, there's really not a whole lot of extra byproducts. Most of it is water. It'll also take care of pollen, allergens, smoke, other particles, and helping them band together to be large enough to caught by standard filters. So let's also talk about the PCO technology. And I've got some more notes on that. So they also had photohydroionization created ions. That's the PHI technology, or PHI. I sold a ton of these in the 1990s. And that is also where the quad metallic sheath as a catalyst over the UVC lights creates oxides, perioxides, superoxides that do similar work as the needlepoint bipolar ionization. However, some studies suggested that over time, as that metallic sheath was exposed to hours and hours and hours of UV light, there was a slight change in the molecular structure, and some ozone was produced. It was cleared by underwriters, brand new out of the box, but over time, I would prefer, my own personal thought was not to do this type of technology, go UV light direct, or go with the I-wave. The other technology is the PCO, or photocatalytic oxidization, and that's the titanium dioxide. And that is also another one that is prevalent to breaking down and creating some dangerous, not nearly as much that the EPA would be concerned, but any ozone is bad ozone in my eyes. So this is how they are comparing the UV light. Only the line of sight pathogens, that is a true statement. Downstream, controls odors. UV light will, if they put in UVV as in Victor light. Airborne particles, yes. Airborne particles like dust and dirt, it's going to zap them. I think that this is a little misleading. Replacement parts every 1 to 2 years, yes. But they're saying no, but yet they are telling me that those carbon fiber brushes are available as a replacement part. Self-cleaning, yes, that was that little bar that ran around and cleaned off the brushes. The entire depth of the coil, yes, because those millions of ions are going to fill the envelope. No mercury. Yes, there is mercury in the bulbs, but if the duct is closed and nobody's banging around inside and you're very careful when you are removing the bulbs, then you are not going to have danger with mercury. Universal voltage, that's a very good selling point of the iWaves, and they have a 3-year warranty. So the R is the prevalent one that has upwards of 6 tons of airflow, or 2,400 CFM. And so that's a lot of millions of ions. And the iWave F and the iWave M, these are the flexible ion generating bars. They're more like a belt. And if this belt, this one is 36 inches wide, and this one is 48 inches wide. These can be installed in ductless split systems, Mitsubishi's, Sanyo's, anything that you want. They can also be installed in small tonnage fan coils. And again, put them between the filter and the coil, and it cleans the coil as well as flows out into the airstream and does their damage to the pathogens as well.
Paul, do these question here, are these linear, these lay flat like linear? They're just coiled up there for display. They lay flat.
No, they are coiled up for display, exactly right. They're like a belt, and you can fold over. They are flexible, so you can fold over and to make it fit into a smaller length. And there's your ballast, or that's the power thing, the power supply, whereas the power supply for the R is in here, but because it's a belt, they've got it mounted remotely. The V, I'll be honest, I have not installed, sold, or really researched this one that much. The C, this is the one that we are actually doing the most of. And the reason is that if you've got your filter immediately up against your coil and it's not a V coil and you've got no room to mount the iWave R, what we'll do is, and they don't want you to mount it in the return because then a lot of the ions are being blocked by the filter. It's trying to work on the filter, which you don't want it to. So we'll put these in the supply duct. And the reason why goes back to that comment I had about the 2 inches to conductive material. This one has a much larger, almost 3 inches, 3 to 4 inches. And then the brushes are on the are inside this white cone area. This also gives you an hour counter so that you'll know how many hours it has been operating, whereas the other ones do not. And this will do up to 12 tons or 4,800 CFM of airflow. So if you've got a 20-ton duct system, what we've done in the past is that I've got 20, 25-ton air handling unit, or rather side ground pad mounted side discharge ducts into the building. And when the ducts 90 up, we'll mount 2 or 3, as long as they are at least a foot off of either end and 2 feet apart. You can put as many as required to get to your tonnage and your CFM for whatever unit you're working on. So the no replacement parts, this is the dirty sock syndrome. So they also kill VOCs, eliminate VOCs, smoke. There's a very interesting video online where they take a glass or a plexiglass, and they've got a cigar and a pneumatic bulb that they pump air through the cigar, creating the smoke. Then they light off the iWave, and literally in 15 minutes, that smoke is gone. It is clear as a bell inside. So it does a great job in that manner. As long as you keep it above -40 and below 160, you're all right. 160, you could get upwards of that on a furnace if you've got it mounted a little bit too close. So a little bit of discretion as to where you want to mount these. So here are saying some of the additional information that we've kind of already gone off. So the product does last a long time. However, the ions are not. And those oxides for the PCO and the PHI, they also have very limited lifespan. But when you're producing millions of these and you're putting them out at your feet per minute, it's going to get out and into the space. And it will actually, with this positive and negative attraction, they are going to seek out, they are going to try to find, with the help of the airstream and the airflow throughout the room, to find those pathogens, allergens, and do their job on them. So this universal voltage is a great thing. Clean a little bit more often on the brushes. And they want you to cycle it with the fan, which is the reason why we put in some of those interlocking devices. Let's see. And on another side note, probably 3 or 4 years ago, we had a 30-year-old oil-fired boiler and baseboard radiation with no ducts in our home. And, you know, the cobbler's son has no shoes. The air conditioning guy had no AC. So that was a primary requisite. And I found out how much the ductwork was going to cost, as well as taking up a lot of my space in the basement. So instead, I went to the hyper heat pump from Mitsubishi, and I put these GPS, or global plasma solution, ion generators in all of my 3 different Mitsubishi air handling units. I can cook salmon, and in 15 minutes, that salmon smell is gone. I don't know if anybody ever wants to get rid of bacon smell. I certainly don't, but it'll get rid of bacon smell too. If you've got pet dander and odors, it'll work on that as well. So these are some of the things that I can personally vouch for, and that personal vouch has also helped me sell quite a few of these. I certainly would not put anything in my own home that would be detrimental. So let's see. Another feather in the ion generation is that they've been used for years in the airline industry. Their ease to install with VOC and disinfectant capabilities make them a natural fit for the closed quarters of people on flights. I mean, have you ever sat next to somebody that you were not happy how they smelled? And this was back also in the day when they allowed smoking on airlines. So this was very beneficial for that. And once I learned that they were putting them in, I felt a little bit safer to take a trip. Not enough now, but maybe later. So these are some of the things that I can bring to the table as far as information. I think that it's important that we as HVAC professionals and you as engineers have to use your knowledge and your ability to design systems to protect the rest of us. And I think that it's a very important thing that everybody is learning about these. And being indoors sometimes is not the safest place to be, but by installing this, you're going to do your job. So I thank you all for staying awake, and I thank you all for listening, and I'll be more than happy to take any questions that anybody may have.
Okay, great. I want to thank you, Paul, and we've got some questions here for those of you who would like to ask questions as well. Please go ahead and type in your questions. What kind of reaction, I guess, do you get on some of these? I mean, some of these more, particularly the bipolar ionization, you know, they're kind of technical. And do you face any kind of issue with, I'm not so sure, it's you know, it makes me nervous, anything like that?
Yes. Literally, they are so concerned that it showed in one study that one guy read that it produced ozone. And that's where I had to have this conversation, and I went online about the microscopic, 10% of microscopic byproducts of this I-wave. And I also did find some UL listing studies that showed that it was not even close to having any type of risk factor. I did run into, we were doing a walkthrough, Josh and I, for one of our customers that is doing clean rooms, and they are manufacturing optoelectronics and static. And because these are statically charged, they were very concerned that these positive and negative charged ions floating around in their clean room were going to affect their product. So that is something that I am going to need to do research on. But other than the byproducts, the ozone, and the positive and negative charged for that clean room customer, I've received nothing but raves, especially after they get a price to do UV and find out that they have to wait 20 weeks for it to come in. And then they look at this price and this readily available. These are on the shelf. Like I say, we bought dozens, and they are coming. If they're out of stock, there's multiple places you can buy them. You can buy them at SG Taurus. You can buy them at DC&E. You can buy them at API. The list goes on and on. Whereas Sanuvox is a little bit more selective as to who their representatives are, because it's a much more technical, and there are safety concerns and installation concerns that need to be followed. They only want to sell to a reputable representative that is going to sell to a good mechanical contractor.
And that's largely because they need the dwell time. They need to make sure they've got the proper setup.
Exactly. It has to be engineered.
Yeah.
These, you can take them out of the box and put them in as long as the CFM's right and you follow minimal instructions.
Mm-hmm. Just out of curiosity, where did you put it on the mini split, on the exhaust? Then you put it on the supply side. Did you lay it like the belt one? Is that the one you used to do the mini split?
No, we just put it on the back wall after the filter, but before the coil. And every single mini split's going to be different. So
Yeah.
Open it up, take the cover off. That's why you've got good, smart technicians and mechanics that are going to figure it out.
Mm-hmm. Mm-hmm. All right. Well, are there any other questions that our audience has this evening? You just type them in, and we're coming up on the hour anyway. I wanted to bring Josh in here and connect him. I don't seem to be able to do that, Josh. I'm trying to still figure out. I see you're on the web here. All I can do is dismiss you. I can chat with you, or I can dismiss you, but for some reason I can't promote you or turn on your mic. So I don't know what's going on there. Usually I can take somebody from the audience and promote them to become a staff member, and that way I'm able to share with them. But I want to thank you, Paul, for being with us tonight and going over this. This is important information. It's timely information, and taking a look at solutions that are available is an important component of our jobs. We all have to know what the options are in our community. With respect to next month, folks, we don't have an exact situation yet with respect to a presenter or date. We are trying to nail that down for next month, and I will be back with an introduction as soon as I have it, and send out a newsletter so that you can all prepare for that. There is one other question coming in here now. Are there any flow-specific methods that can prevent lateral mixing, similar to the air curtain we saw earlier, perhaps? Are there any airflow-specific methods that can prevent lateral mixing?
Well, I think your modeling of your airflows that you personally have would help in that. You're just going to have to design your diffusers for proper throw, for proper reach. I would just say that make sure that you're getting your proper air changes, follow your ASHRAE guidelines, increase your outside air. disable your demand control ventilation until we get through the pandemic, et cetera, et cetera.
Yeah, you are right. And the user here, or the customer, or the participant is Davis Cole. And what you do find, Davis, is that each room is unique. It is the modeling we've done, the airflow modeling we've done in buildings suggests that every room has its own idiosyncrasies. And part of what we're doing with the solution we're building is doing the modeling along with it, so we can provide guidance. It surprises even me sometimes. You know, you say, well, I'm going to put one here and put one there. It makes good sense. And then you run a model on it, and you realize, you know, the dead spot's over here. And then once you run the model, you start and you go, well, I should have known that, you know. But I've been doing it 30 years, and it still surprises me sometimes. So, and the modelings get cheaper. You can do a model now pretty inexpensively, so that you can set up the diffusers as long as you know where they are, their size, and you get a couple of velocity readings on them. You can do a good approximation with a CFD model of where the dead spots are. Yeah, Josh, Josh sent me a note here. He wanted to remind people that we do have an in-person audience. We have 3 attendees today. They're at the Fox Den. They're hanging around with the Foxes over there at the Red Blazer. And certainly any one of you who want to participate in person, we are going to eventually try to do a hybrid presentation where the presenter will be there with us, and we'll be broadcasting from there. But at the moment, we do have a few people over there, and if you're interested in coming next month, we'll give you the date and we'll reserve the room, and you could come and socialize with your fellow ASHRAE members, albeit probably wearing masks. And maybe we'll bring a COVID air curtain with us, so that a clean air curtain with us, so that we can clean the room up in there. All right. I want to thank everybody for being with us today. This is being recorded, so if you'd like a recording, please, you should get a link afterwards to the recording. You'll get an email, I hope, from GoToWebinar. That's how we set it up, so that it'll have a link to a recording, and there also should be a survey that will come. So I encourage you to fill out the survey and let us know what you think of things, how to improve things, what topics you might want to see in the future. And there will be a recording if you want to share it with any of your colleagues or what have you. So thank you again, Paul, for being with us tonight and sharing your—
My pleasure.
I think you said 130 years of experience is what I think you said. Is that—
Well, quite frankly, I'm a little surprised that I was able to rattle on for an hour.
Well, thanks for being with us tonight, and I really appreciate it. Have a good evening. Thanks, everyone.
My pleasure. Thank you.
Bye now.